Yeah, that's right. It's going to be pretty related to the talk that we just heard, and also related to the previous talks about the whole monadic, Haskell, functional reactive programming stuff. But I won't really mention any of those words by name, so if you weren't paying attention, that's fine. Also, I'm battling a cold right now, but luckily I have your country's medicine for all things. I'll be using this maybe throughout the talk, but I just want to apologize if I have a hoarse voice. So the title is Functional Layout, updating the DOM at 60 frames per second, and I feel like the title is a little obscure, so I want to just mention what these words at least mean to me. So for layout, all I mean is rectangles on a browser in a screen. Their positions, their orientations, their heights and widths, but I don't care anything about content, just the distribution of these things on the screen. For updating the DOM at 60 frames per second, we're concerned about how do these rectangles move over time. So whether you're scrolling, or they're animating, or you're doing responsive design, these things are all happening continuously, and that's the stuff that I want to talk about. And functional has two meanings. It's a double meaning, and I'll be talking about both of those here. The first one is, what does it mean for layout to be dysfunctional? And I would say that layout isn't dysfunctional at all for static or mostly static websites. So whenever you have like a few animations, maybe they're simple, like they're an animation in or out, or their website isn't static at all, I think that the layout primitives that we have in HTML and CSS are perfect. But if we're to compare ourselves to native layouts, I'd say it's a really constrained language, especially for kind of continuous motion. When it comes to coordinating animations and things like that, I don't think the web is really well suited for that, and I don't think that we have a strong language to express it. So what's holding layout back? There's the obvious one that a lot of people talk about, which is performance, and usually that comes down to reflow being really costly, especially when you have a nested DOM. Many elements are dependent on the layout of other elements, so once one element changes, the browser has to do expensive calculations. But I think something that we don't talk about is expressibility. And I'd say that we don't actually have the right primitives, the right language, to really talk about doing rich animations, coordinated, gesture-based kind of layout that we see in the native world. So I think we'll all agree these are the three pillars of the web. And we can ask, where does layout belong? And layout is the purview of HTML and CSS. HTML, usually you don't think about as doing anything with layout, but HTML makes its own opinions on layout. The normal browser flow. Block elements are placed underneath each other, and inline elements to the side of one another. And you can think that CSS is really just there to modify this kind of flow in a separation of concerns kind of way. All the attributes of top, left position, flexbox, transform, floats, tons of layout things in CSS. But it's important to note that HTML also makes an opinion on layout. So we have this idea of layout, and it's inside of two objects. The whole point of separation of concern is that HTML should not be concerned about layout. And then there's the lonely guy JavaScript out to the side. And you can think that JavaScript is being able to modify CSS on the fly, or maybe HTML too. But usually when we think about layout, we don't think about JavaScript, and that's what I'd like to change. If I were to organize these, HTML would be static layout. CSS would be about a binary form of layout. And what I mean by that is you can always add a class, add a style, and it's like flipping a switch. You might change the color, or you might even queue an animation, but still it's you're flipping a switch. You're not continuously changing some piece of data, even though the animation is continuous. You're just turning something on or off, and then maybe queuing a continuous thing. The simplest thing from the native world that we can see is even just moving a div, following a div by your finger, doing like a swipe gesture. And even just the most basic thing like that I'd like to create is you need to include JavaScript. There's no way to do that in just HTML and CSS by itself. So I talked about the separation of concerns. HTML is supposed to be just about content, but many people find themselves in this tag soup where they start wrapping the actual content in other tags just to do something about presentation. Flexbox goes a long way in helping this, but Flexbox is also has reflow problems and other things like that. I don't think it's the right. It's a great solution for some things, but it's not I'd like something a little bit more powerful. So I have a question. Why do we use HTML for presentation? If we really had this abstraction of concern, you would never even see this. We would have some other way of saying that the div, the content, is centered. It wouldn't be in HTML. And my answer to this question is that it's the only tree around. And layout is necessarily a tree kind of data structure. Things are positioned relative to other things. So you have this natural tree that comes out of play. But there is no other tree in the web. There's just HTML. You can think that CSS is kind of like a tree with its cascading, but that's just a layer on top of the HTML tree. So not that that's a bad idea, but what I'm about to say might be a bad idea. I have this idea. You can tell me if it's bad. Can we virtualize, can we actually create the separation of concerns where we have a virtualization layer where we turn some kind of layout DOM things and we flatten it down into style properties? We do this inside of JavaScript. So is there some way to go from the top to the bottom? And browsers do this at a very low level anyway, because they're always drawing things to the screen. You don't know how they're doing it. And so when you're not looking, this is what they do. These slides are a few years old, so, but I'm pretty sure that things are similar. This is both web. Now Chrome uses Blink, but Chrome and Safari use WebKit as a rendering engine, and Firefox uses Gecko. And they both have this thing called a render tree or a frame tree in the case of Gecko. And what this is it's just a representation of your document in terms of rectangles. So WebKit and Gecko, they take the DOM and they take your CSS styles and they parse everything. And at some point in the pipeline, the only thing that they care about are rectangles on the screen. And then they paint those rectangles with your content. Okay, so what I'd like to do is take this part out of the browser and into the hands of the developer. The way that we do that is kind of crazy. We position absolute things in CSS. Now, this isn't everything. This is just the things that we want to animate, the things that we think are presentational and not to do with content. And we create our own render tree in JavaScript. So that way, by positioning absolute everything in CSS, we've taken it out of the browser's normal flow. We have manual positioning on things. So we can create this render tree in JavaScript. It's a pretty ghetto version of a tree right here. A bunch of nodes, and the leaves of these nodes of this tree are actual HTML divs. Okay. We can give these nodes some kind of properties, some layout properties, maybe some translation. If we give A and B these translation values, then we'd expect, before it touches the DOM, that we can flatten this and style the DOM 150 pixels by 200 pixels, just the combination of the two previous nodes. And we can be clever with other layout properties, too, the things that we see in CSS, the percentage-based properties. We can define C with some kind of size, and then we could align D relative to that parent size. And so that would be, just C and D would be a combination of 50 pixels to the right and 25 pixels down, combined with a translate from A, and we get 150 by 225. Oh, God. Everyone should use GPG. Oh, I have a demo. OK, so the logical this is to remind me when the demos are, actually. So the logical conclusion of this, if we take it to the point of absurdity, is to build a tree in JavaScript, or we'll build a tree in HTML, but actually everything is flat. If we inspect the element here, and I scroll down here, that's the first node, second node. All of these things are on the exact same level. It's entirely flat. So you can do this in CSS. You'd have some crazy nesting thing going on, 8 layers deep. And there is content here, and I just tried to be can you see that? There is content inside of these. There's a little smiley face, and just for comedic effect, I put it inside of 2 spans, just because, I mean, you can nest whatever you want inside of here. The important thing is that the outside is flat, not the content. And close this for a second. And we can animate this tree also. So the whole point is to have all these animations going on. And we avoid the problems of reflow here because everything, well, one, it's all hardware accelerated. You kind of learned what that meant in the last talk. And two, everything's flat, so the DOM has to do very little recalculation. So you can imagine that there's this tree going on, and just the numbers inside the nodes are changing, and they trickle down. So one branch moves, it moves all the other branches, but those branches move too, and then you have this funny tree. OK, back to the talk. You weren't supposed to see that. OK, so you might have seen this class there called Samsara Surface. So this is Samsara is this library that I've been writing. It's originally a fork of Famous. That's where Miles and I both worked. It's meant to kind of be a language for this kind of stuff. And some of the ideas are similar. OK, so with layout in JavaScript, the question is, what can we now do? And I have this theory that CSS was always designed for point and click. You have the hover attribute, or you have an animation that goes on and off. It's not about continuous motion, but JavaScript can be. That's the whole point of JavaScript. And I'm super excited about streams, as you can tell. That's the largest font size in the entire talk. And all these ideas of functional reactive programming, too, that you might have seen in the other talks, because we can think about CSS not as this tree, but as one giant stream. So streams are kind of the language for continuous motion, or just kind of continuous data flow at all. So let me give you, let me show you a demo of what I mean that's a little bit less abstract from the previous one. Yeah. So this demo also works on any of your mobile phones or your computers and stuff. If you go to that bit.ly address, you're welcome to. That O is a O and not a 0. This demo is supposed to mimic some of the ideas from the native world, specifically the iOS navigation controller, where you give it, it kind of does the menuing interface for you. It allows you to have a back button, and then it does all these crazy transitions when you actually go back between some kind of modal, pages that you have in your application. So there's a lot of things going on here. When you drag, here, I'll just drag first and then explain later or whatever. That's all this demo does, pretty much. But there's a lot going on. So you can see things that opacitate. In fact, they opacitate at different rates. I was trying to be neurotic to emulate iOS. They translate. The drawer that you see, the red part, actually comes out, but then it doesn't move for a little while. You can do all these kinds of crazy effects with streams and stream transforms. And more than that, the way that this code is written is the way that I think about it. The opacity of my nav bar is listening to the motion of the drawer, which is listening to the mouse input that I'm giving from my dragging. In a lot of other animation libraries, they give you the ability to wrap a node and then animate some CSS property. And that's great. It's like you want to change one thing, have some enter or exit animation, that's fine. But I want you to feel like you're a conductor of an orchestra, that everything is interrelated, because this is the kind of experience that we have in the native world. You don't realize it, but when you press the back button on iOS or in Android, 8 different animations are happening. And I actually think that this is part of what makes those interfaces so fun to use. You can also click on the message button and the back button or something. Yeah, so this is all done in the language of streams. Everything is a stream. The mouse input is a stream. The layout itself is a stream, because the blue thing is actually emitting a bunch of numbers from 0 to 1. And it's, if you think that my mouse input is going from right to left, it gets clamped at some point. And so only ones are being emitted from the blue thing, and then the nav is listening to the blue thing. And that's how all these things are being piped together. That's how this demo works. And it's, I think the whole thing is about 300 lines of code, but it's, there are other frameworks that allow you to give you these 2 pages and then let you give you that animation. And they make it extremely simple. But to customize it is almost impossible. So what I'm trying to do is make simple things medium difficulty, but make hard things just as medium difficulty. So I'm trying to come with the primitives in order to give you the power to do whatever kind of animations you want. OK, so I've already lied to you. The render tree isn't a tree at all in the Samsara framework I'm making. It's one big stream. That's, to me, kind of a nerdy, cool part. And I love to talk about the technical parts, especially to some of the Haskell people that were speaking before. But the whole idea is the nodes contain streaming data, and then child nodes listen to parent nodes. And when parent nodes change, they send data down to the children, all the way down, until it exits in the DOM in the form of transform, opacity, or size properties, all the layout things that I essentially need. And this has a lot of technical benefits. You don't, like normally you think of a tree as like you have a node, and then it has array of children, and you might call render on the root node, and then it calls render on its children, and recursively it goes down. But when you think of it as just one big pipeline, you can do things like you have optimal subtree rendering. You don't have to ever parse the entire tree. When one thing changes, it will naturally just cascade down. You don't need to do any dirty checking, or there's like tons of things that you avoid with this streaming interface because there is no state. The way that it goes down to the div is it just goes from one function to another function to another function, transforming the data, composing it. And there's like an algebra for all of this. So transforms are matrices, essentially. They multiply. Size and align might combine in some other way. So these are all just transforms that trickle all the way down into the DOM. So Doug McElroy said, write programs to handle text streams because that is a universal interface. So doing I/O is you're often using text streams. And I think that's part of the reason why Node was so successful. You're always using this streaming language inside of Node. And it's because they wrap themselves around their Unix file system base, which is about using these streams. And what I'd like to convince people, because I don't think we normally think about it, is that continuous motion inside of layout can be thought of as a stream. And JSON data is the universal interface. Okay, I'm nobody, though, so maybe you shouldn't listen to me. But none of this is new either for the web. Okay, the web started us off with streams. We've just blissfully forgotten about it. Every single DOM event is just a stream. Mouse move, there's other ones, scroll, resize, et cetera. The DOM starts us off. But the cool thing about streams is you can take one and then you can move it into another. You can transform it. So what's lacking is the ability to pipe these streams around. And if we have this ability, there's so many things that we can do. In the demo that I showed before, I had this layout widget that was subscribing to the mouse input and changing itself, whatever. But you can have gesture recognition. So you take in the touch input, and it's historically accumulating some of the events, and then you figure out, oh, this was a swipe left, or somebody drew a circle, or something. But this is the right language to talk about these things, where you build higher-level streams on top of lower-level streams. Calculate the velocity from scrolling, or maybe you're tracking 2 fingers at a time, and you want to have some stream that turns that into a pinch to zoom. Whatever that means. So there's tons more I can think of. And what I'm trying to do is come up with the right language to talk about this stuff. So I think that with ease of expression, people can suddenly begin to experiment more. And they can do things that they didn't normally try. We have had drag and drop for a while. Who remembers not having inertial scroll? It's like we're crazy not to have inertial scroll. It feels so weird. Bounce to refresh the hamburger menu, and the question is, like, can you just insert your own here? Can you just start playing and come up with something? All right, what's this one? Yeah, so here I started playing. This was super silly. That's also a bitly that goes to it, so you can play around with it. But yeah, everything's in 3D also, so like you can change skews and translates and move things around in 3D space. And this is just a little joke thing, but it's taking the mouse input and then it's moving things around. And I guess Gmail actually uses something similar to this kind of accordion thing by when it collapses and expands threads inside of an email. So believe it or not, it can be useful. Oh. All right. So just some closing thoughts. I think a lot of us would say that in the past 20 years, the public internet has done a lot to change society, maybe the most impactful. Maybe more debatable is in the past 10 years that mobile has done a lot to change society. But as Miles introduced me, he said that I was traveling for a while. I've been traveling for a while. I've been to some remote places. Maybe a year ago, I would have said, like, oh, mobile's pretty important. But I was in Myanmar. It's also already pretty kind of closed off. But then I was in the Shan Hill tribes of Myanmar, living in the mountains with these people that are completely autonomous from their central government. And there was this girl, I had a camera with me, and I gave her the camera, and she started taking all these pictures. And I showed her how to, like, move back and forth. She had never seen a camera before. But her first instinct when she was looking at the camera and trying to move back and forth was she swiped the screen. And I didn't understand. I was like, you've never seen a camera before. How do you even know how to swipe? How do you know this gesture? And through the guide, he translated, and she was like, oh, well, somebody in the village has a smartphone, and we play games on it, and we charge it with the solar power that we get from, our solar panels. And I was just like, mobile is everywhere. I mean, really, I didn't quite understand. And this happened several times. People in Myanmar gamble over mobile games. It's so weird. It's so interesting to see. Anyway, so I definitely have this opinion that mobile has, in terms of its pervasiveness, transformed the world. But the whole is not greater than the sum of its parts. The mobile web is certainly lagging behind. And I'm not trying to package up a dream that the mobile web will win or anything like that. I've been around that world. What I'd like to do is try to say that it's important to work on. And that's what I found in my traveling. So here's a potential future that I can think of for the mobile web. I think the mobile web can actually change the economy of applications. Apps can be downloaded, sorry, maybe I should have said downloaded by hyperlink. I can text you an application. I can tweet an application. These are the ways of distributing apps that are completely decentralized. I don't have to go to an app store. You may have opened hundreds of browser tabs in the last couple of days, but how many apps have you downloaded? It's very different, the way that we think about downloading apps and looking at websites. Everything has a browser, so whether it's this computer or my phone or maybe the TV or your car, there's no problem in an Apple phone communicating with an Android phone when it's over the browser, but there might be a problem if it's AirDrop. So everything has a browser, and it can be the layer that unites all the other things. You can, searching in the Apple Store sucks. You can crawl through apps, and that data can be, any other app could use that data. And you could not only just find the app that maybe you're looking for, but also have a layer on top of the app that crawls it. And I'm really big on this idea of ephemeral apps. So what I mean by that is since there's very little barrier to downloading an app, you never have to really think about it, because you never think about opening a tab in your browser. It's not like, man, am I going to open this tab? Am I going to uninstall this tab later? Imagine just walking into a department store and then they text you this application that just has all of their inventory, and you can search it. Or maybe it's even just you try to access their Wi-Fi, and that's the website, is their website that shows their application. And you get rid of the app just by closing a tab, so you never have to worry about it. So I think that not only can the mobile web compete kind of with native, but it has all these other things that going for it that we're not really exploring. So yeah, with that, that's it. Thank you. That's my Twitter. That's where the code is.